Congruency, remember, means same size, same shape. So if we're going to talk about congruent angles are angles with the same measure. For instance, if we have an angle that looks like this. Now remember, we name our angle. Let's put our arrows on our rays. We've got a vertex. Let's call it B. Let's have ray BA and ray BC. Now this angle, remember, can be called angle B, or it can be called angle ABC, or angle CBA. Let's say this angle is 85 degrees. If we have another angle that is also 85 degrees, we say these two angles are congruent. We mark it with an arc. These are congruency marks, and they show that these two angles are congruent. Now let's give this angle a name as well. Let's call it angle DEF. And the way we would write this is that angle ABC is congruent to angle DEF. That's what we mean by congruent angles, the same measure. Now our angle addition postulate says if a point B, is in the interior of an angle, and we need an angle symbol there, angle AOC, then the measure of angle AOB and the measure of angle BOC equals the measure of angle AOC. Now what all that is saying is, if I have an angle and, for instance, the vertex we label O, and point A and point C. So we have ray OA, ray OC that form angle AOC. Then we have point B somewhere here inside the angle. That's the interior. And we have ray OB. Then if we take the measure of angle AOB, whatever the measure is, and add it to the measure of angle BOC, whatever the measure is, we will have the measure of angle AOC. That's the angle addition postulate.